So let's continue as we look at question number 4. It says figure 4.1 shows two identical loudspeakers placed facing each other. Then each speaker produces sound at a frequency of 1500 Hz at the same time. Maximum of intensity, so it says maximum of intensity are formed at regular intervals along a line joining the speakers. So there's a line joining the speakers as they have shown. Then the distance between successive maxima is 0.11 meter. What property of wave is responsible, I think that was a repetition, is responsible for the maximum? Now for the maximum to, the point where the sound is actually reinforced, it simply means that interference was happening. So you could have actually said interference, or you could have said constructive interference would have actually taken what place. So that actually is responsible for the maximum, that the maxima that are going to be produced. And one thing that you need to remember is that for sound waves in a stationary wave pattern, the distance between maximum is equal to half the wavelength. So what I mean is that, and that's why it says determine the wavelength of the sound wave. So it is half the wavelength, that is the distance between maximum. So let me just give you a clue there so that you need to remember. So for sound waves in a stationary wave pattern, the distance, so you need to remember the distance between successive maxima is equal to half the wavelength. So it is equal to half the wavelength. So the distance is equal to half the wavelength, and that's what we are going to use. So if you want to find the distance, it's half the wavelength divided by 2 equal to the distance between the maxima. And they told us the distance between the maxima was 0.11 meter. So you are just going to say wavelength over 2 is equal to 0.11 meter. Remember, you can solve one and cross multiply. Therefore, your wavelength will be 2 multiplied by 0.11, which will give you 0.22 meters. So that is simply the wavelength. So 0.22 is simply the wavelength. Then it says we determine the speed of the sound wave. So remember, from the wave equation, speed is equal to frequency times wavelength. So the frequency, they told us the frequency was that 1500 Hz times the wavelength, which we just found 0.22 meters. So therefore, what will be the speed? So it will be 1500 multiplied by 0.22, and that will give us 330 meters per second. So that was the wavelength. Then it says what factor affects the quality of sound? So the quality of sound will actually depend on the waveform, or you can simply say harmonic content. So the harmonic content. So the quality of sound is known as also as the timbre. So the waveform or the harmonic content, or you could have said in this case the number of, maybe we can say number and relative, let me say number and relative intensity of overtones, or you could have said harmonics, so the number of overtones. So you might actually have some in your sound that are created what we simply call as being overtones. So they will affect the quality. They may be played with the same because of the frequency, but because of the overtones there, the guitar and the piano will actually differ. So that is what they wanted you to do there. All right, so watch out for my next video as we look at question number 5.